My name is Tyler Dean, and this is video problem 3 for linear algebra at Hiram College. So today we are practicing with matrix transformations and what they mean and how they affect lines and objects on a graph and how we can show and express those transformations through matrices. So for our example today, we are using Wolfram demonstrations, and we're using the change the dog. So as you can see, we have a normal dog graph. And our problem is to find the matrix changes, or the matrix that changes the dog to the image given below. As you can see, the dog is very distorted in a very weird way, from the black shape of the original dog to the blue shape of the very distorted dog. Poor puppy. So basically, the transformations that we found, or I found, were -2 for A, 0 for B, 2 for C, and -2 for D. That is shown by the left picture. These this matrix of transformations gives us our transition between the two dogs. And here's the sliders that I had for the changes. So for physical representation, A flips the changes the positive x, or like how it is. So if it was positive, it would have made it grow on the x. But since it's negative times 2, or -2, it flipped it across the y-axis onto the negative x's and made it twice as long. Next step is basically it just takes all the y values and turns them or stretches them depending on how big the value is, and if it's negative, it changes the sign. So as you can see, we went from positive y's doggo to negative y's doggo, and since it's a 2, it's times 2 the original, so now it's twice its original size, both length and height. And the final part is C has a 2, so that means it is stretched in the positive y direction. And as you can see, that the dog has dramatically changed from its doubled size to now this lengthy diagonal weird dog. I don't even think you can call it a dog anymore. So it's stretched by a factor of 2, and I guess a little detail is that if you look between the two, all the lines or the angles actually changed by 45 degrees. Actually, that is not it. Ignore that. That is not true. It's only true for some of the lines, such as the ear. Now, we come down to the matrix. We need to find 3 matrices that found or transitioned to our doggo, or final doggo. So I had 1, 0, and 0 and 1 times -2, 0, 1, 1, which gave us our -2, 0, 1, and 1 over here. Then we used that and just multiplied everything by 1, which gave us our original matrix, which is what we used for the doggo, which is this. So now we have matrix 1, 2, and 3 for the final matrix of the doggo. Thanks, that's it. Thank you.